Hello friends, welcome to this video on analytic function. The topic which we will be seeing today will be about conformal mapping. So we will see what is meant by transformation or mappings and in particularly what is meant by conformal mapping. Mappings and transformations. Say suppose we have a complex number of the form z is equal to x plus iy and one more complex number of the form u plus iv, and we have the function to be defined as w equal to f of z. So we are mapping u plus iv to the function f of x plus iy. Now this mapping or this identity will involve four real variables. What are they? X, y, u and v. Now if we have to plot this graph of u plus iv equal to f of x plus iy, I will be requiring a four-dimensional graph, but that's not possible for us. So to overcome this difficulty, what we will be doing is we will be using two complex planes. One complex plane for the variable z is equal to x plus iy and one more complex plane for the variable w is equal to u plus iv. Then if we have a point z that describes the curve C in z plane, this transformation or the mapping will have the point W to describe a curve C dash in the W plane. This is defined as a mapping or transformation of Z plane into the W plane. So what primarily happens over here is, say suppose we have the Z plane which represents the Z plane which represents x plus iy. So we have x-axis over here and our y-axis over here. And now we have the other one to be the w plane. So we have this one as our w plane. What happens in our w plane? We will be mapping the quantity u plus ib. So along this direction where we had x, we will be having our u, and this direction where we had our y, we will be having a v. Now this takes care of the two variables x and y, and this takes care of the two variables u and v. So instead of a four-dimensional graph, this two-dimensional graph and two two-dimensional graphs will be easy for me to define the process. Now, whenever I have a curve over here in my z plane at any particular point, the transformation w equal to f of z will give me a different plane that will be defined in my w plane. So, whatever is going to be the input, this w equal to f of z converts it to the W plane, and then a identical transformation or a mapping is defined in your W plane. Now this is about mappings and transformation. Now we will see what is going to happen in conformal mapping. If the transformation is such that the angle between curve 1 and curve 2 at any point x comma y is equal to both in magnitude as well as sense between the quantities d1 and d2 at u comma v, then the mapping is said to be conformal at x comma y. Okay, like before, we will have two planes, one to represent the z and the other one to represent our w. So let this represent our z plane, and this is going to be my x-axis, the y-axis, and the next one is going to be my w plane with U axis and V axis. Now if we have two curves over here, say this is going to be the point and I have a curve called as C1 and one more point called as C2 at the point x comma y, and this is going to be the angle of orientation alpha. So if this is going to be mapped or transformed into curve D1 and D2 at any particular point in my W plane in such a way that the curve D1, the curve D2 has both the magnitude, that is the quantity alpha, and the sense, namely the direction, is preserved, is going to be the same. Then this kind of transformation or mapping is called by the name conformal mapping. So you have it to be conformal if the magnitude and the sense between any two curves is going to be preserved. Now, what happens if they cannot be preserved? We say that the transformation is isogonal if it preserves the magnitude alone, but not necessarily the sense of the angle. So, how can this be visualized as? So, again, let us take our z-axis and z plane, and what we require is going to be the w plane. Okay, so what we have over here in the w plane, if this is going to be my u, this is going to be my v, and over here if this is going to be my x and this is going to be my y, in the z plane, what happens over here? Like priorly, I am going to have a point and I am going to have two lines or curves, one called as C1, the other one called as C2, defined over here, and this is going to be the alpha, the angle. If the magnitude is going to be preserved, that is the alpha is preserved, but what happens? The sense or the orientation of the angle is not preserved. Say suppose I have the curve to be forming in this way, where this is D1, this is D2, and we have this to be the same alpha. So now what has happened is the magnitude of alpha has been preserved, but the sense or the orientation of the angle is not preserved. In which case, this kind of transformation is referred as isogonal transformation. I now suppose you would have got the difference between what is meant by a conformal transformation. A conformal transformation is one that preserves both magnitude and the sense. So you call it as conformal. If it preserves only the magnitude but not the sense, then the transformation is referred as isogonal. Now, there are going to be points by which I can show that a mapping is going to be conformal. How can that be done? A mapping W equal to f of z is said to be conformal at any point z is equal to z naught if the derivative at that particular point is not equal to 0. So, if I can show that the derivative exists at a particular point, then the mapping is said to be conformal at that particular point. So, what happens if the derivative is not going to exist? or a point at which the mapping is going to be not conformal. So whenever we have quantity where it is not conformal, then such a point will be referred by the name as critical point of the mapping. So what will happen, or how can we estimate a critical point? A critical point of a transformation is got by the condition dw by dz is equal to 0. That is, if the derivative happens to be equal to 0, then we say that the mapping is not conformal at that particular point. So we will see some example to find out what are the critical points of the transformation. Example number 1. Let us consider the transformation w is equal to z square. So let us find what are going to be the critical points of the transformation given by. So to find the critical point of the transformation, let me estimate what is going to be dw by dz. Differentiating on both sides, I have dw to be equal to 2z dz. So dw by dz will be equal to 2 times of z. How do we estimate the critical point? Critical point is given by dw by dz equal to 0. So now I have 2z equal to 0, which leads me to z equal to 0. So at which point is this transformation not conformal? The point at which w equal to z square is not conformal is at z equal to 0. So the critical point of the transformation w equal to z square is z equal to 0. We will take one more example. Find the critical point of the transformation w equal to f of z, which is given by sine z. Now let me find out the derivative dw equal to sine on differentiation is cos z dz. So what will be dw by dz for me? So this will be cos z. If I want the critical points, how to get the critical points of the transformation? Critical points are given by dw by dz equal to 0. So I have cos z to be equal to 0. What are the points at which cos will become 0? As such, we know that cos will become 0 at 90 degree. But that's not the only point at which my cos will vanish. My cos will become 0 when I have z to be equal to plus or minus 90 degree, that is given by pi by 2, plus or minus 3 pi by 2, plus or minus 5 pi by 2, and so on. So there are going to be infinite critical points for this transformation. So in general, I can write these points to be of the format 2n minus 1. So how to generate the odd numbers 1, 3, 5 and so on? They are going to be 2n minus 1. Put n as 1. 2 into 1 minus 1 is 1. Put n as 2. 2 2s are 4 minus 1 is 3. Put n as 3. 3 2s are 6 minus 1 is 5. So you have 2n minus 1 to generate the odd numbers divided by 2 with a pi. So z is equal to plus or minus 2n minus 1 divided by 2 times of pi, where n is going to be an integer. So when we say n is going to be an integer, this can add both positive and negative. So for this quantities, when n is going to be an integer, we have the critical points of your function or the transformation sin z to be generated. Thank you very much.